this as well. Okay, so yeah, so today what we're going to do is we're going to talk about, there's two sets of slides, kind of the background of software process, kind of an overview of software process, and then also we will, there's the second set of slides, it's about the CMMI. It has to do with capability maturity model to help us understand what maturity level a software process, a systems process might be at. And then I also, you should have seen in the class materials, there should have been uploaded a readings folder. So there's a directory called readings that I want you to take a look at. These are where I'm going to place some papers that I would like you to look over at some point. I will go ahead and I'm going to give a first assignment that is going to be based on some of the papers in this folder. So over the course of the semester, there's already, let's see how I put in like nine papers in there already. And over the course of the semester, I will add to that. And then I also gave there's a folder in there called example presentation. That was my presentation, similar to when I had a class similar to this years ago. And so I would like you to take a look through that if you want to get an idea of how I presented a research paper based on software quality and software quality assurance. So, okay. All right, so we can just get on into it. So there's two sets of slides. Let me see, where are you? Okay. All right. So here. All right. So the first thing we're going to talk about today, we're going to kind of briefly, like I said, go through kind of an overview of software process and what is it, because unfortunately for a lot of software developers, for a lot of programmers and people in the software industry, we don't do as much thinking about how we get to the product as we do we just kind of think, well, we know how to do it and we're going to write the code and it's going to work and everybody will be happy, right? And so in the past few decades, there's been a lot of research, a lot of work done to help us understand that it's not just about writing the code, that the process of software development has a lot more to do. Well, there's a lot more based on the before and after the coding part. So we kind of think of the coding as being, that's how the software is written. So it's kind of like if we were to think of an example, building a building, we might think, well, the main important part is, putting the bricks on top of each other and making sure that they're in place correctly and making sure that the cement is done properly, right? So we think about the building part, but there hasn't been, at least in recent memory, there hasn't been a building built in a developed country that wasn't first architect, right? There wasn't first an architect involved with creating the design for the building, right? In fact, I mean, you guys, I know in a lot of places in Turkey, things are named after the architect that designed it, right? So you have different buildings all over Turkey that the building name, and people know this was done by this mimar or this mimar, right? There's a lot of honor given to those who designed the building, even though those guys may or may not have ever laid a single brick, right? They may not have been involved in actual physically building it, but they're the ones who get the credit for designing the building. And so in the same way, as we develop our software projects, we need to make sure that we do a good job of planning them and then making sure, even before a single line of code is written, that we're on the right track to where we want to end up. Okay, so that has to do with software process. That's kind of an overview of what software process is this idea of designing a plan, not only for designing the code that's going to be written, but also making sure after it's written that we tell that it does what it's supposed to do, right? So it's much like, I mean, unfortunately with a building, the only way we can kind of know for sure, like the building that I'm sitting in right now, I'm sitting in my apartment, as are probably the both of you. And the only way I can know that this building is built well is as long as it doesn't fall on me, right? And that's not a very good test, but you know, it's one of the only ways that we really have at this point, right? So yeah, it would be a bad thing if it failed that test, right? Yes. But the nice thing about software development is we can plan our test activities so that we can be reasonably sure that when they get out to the customer, they're not going to fail a lot of tests with them, because the customers will have their own testing as well. Okay, so some main activities, some activities that might exist as part of a software process is the analysis, the design, and of course the coding. So before we even start writing some code, we might want to analyze, okay, what are the requirements? What is it that the customer wants us to do? How do we design that? How do we make a plan? So if you've ever done anything with flowcharts or pseudocode, this would be part of the design phase, right? Where we would take the idea of what we want to do and we put it into a form that's not code, but we can easily take that design and make it code. And you know, after we're done with coding, during coding, after we're done with the coding, we want to know what our test plan is. How are we going to test to confirm that software does what it says it's going to do, or it says what it's going to do. Some other umbrella activities that might not be specific tasks might be configuration management, if you know what that is. So the idea of configuration management is that, especially on large projects, you don't want necessarily to have everybody have access to all of the software to be able to write the different code, but we kind of can divide up the activities, divide up the sections of the product. And so, like for example, right now you're looking at PowerPoint slides. You probably have at Microsoft, you have a team that their main job is PowerPoint, right? And making sure that PowerPoint runs. And they are not, the configuration management, one of the things they're going to do is make sure that the PowerPoint team doesn't get access, unless they have a need to, doesn't get access to the Microsoft Word code or the Microsoft Excel code. So there's not a lot of overlap there, right? But sometimes it happens, but configuration management will be in control of making sure that does, that they only have access to things that they need to have access to. Okay, so let's talk about, so we'll talk about some of the software process models and processes that might get used. Maintenance. So maintenance is what happens after the initial product is delivered. Sometimes maintenance can be stuff like corrective, can be fixing defects, right? And this would be stuff where like the customer finds a bug and reports it and we have to change it. Some of those can end up waiting until the next release. Some of those may be so problematic that we need to rush out a patch to be able to get it working appropriately. Perfective would be additional things, like if we want to add new functionality. So this is something the user or customer didn't originally ask for, but they want it now. Things have changed, stuff like that. Adaptive, to adapt to changes. So that might be some security stuff might be related to that. Preventative, sometimes we might even, you might call this refactoring, put into a more easily maintained form. So this would be like, if code is not very easily understood, we might be able to change it so that it's understood. It's not that the old code didn't work, it's just that the old code might have been harder to understand. And so we might need So this is a chart of basically kind of the percentages of maintenance tasks, maybe divided up generally. So perfective would to expand. So perfective, the majority of our maintenance is going to be expanding beyond what is already there. Okay. So we'll talk through some process models of how they work, and some parts of process models like prototyping. Okay. So build and fix, sometimes often referred to as ad hoc. I often talk about how this is how first-year programmers in your computer science and computer engineering courses, this is how first-year students do their coding. Because basically what happens is we write the code, we run it. If it doesn't work, we fix it. Then we run it. If it still doesn't work, we fix those problems. And we keep doing that until it works as far as we can understand. Then we go show it to the customer. The customer says, no, this isn't working, because they find problems with it that we didn't find. And we keep doing that until basically the client says it's okay, it's good, and then we ship it. Okay. This is really a bad way to do software development, just to kind of sit down and start typing code out until the problems are all gone. Because part of the problem is that if you don't make a plan, there's an old saying that if you fail to plan, then you're planning to fail. And so the idea is that if we don't start out with analyzing the situation and making a plan on how to get where we're going, then we're going to end up with lots of problems later. So if, for example, I needed to drive to Ankara. I'll use Ankara a lot as an example because we used to live there. But if I needed to drive to Ankara, and if I just said, okay, I'm just going to get in the car and start driving until I get there. I'm not going to look at a map. I'm just going to start driving north, and eventually I'll get to Ankara, right? Well, think about how many problems might come my way if I just start driving. I'm not looking at road signs. I'm not using a map. I could end up in a lot of dead ends. I could end up, I remember one time on our way, we drove from Antalya to Ankara one time, and we followed actually Google Maps at the time and ended up on this one-lane gravel dirt road through a village in a mountainous area by a lake, and it was in the middle of nowhere, you know. But Google Maps took us there, so I trust them, I guess. I don't know, but the reason why I use that as an example is because if you don't plan initially, if you don't plan in advance, you don't get a map, you don't put it into your phone for directions, you don't look at road signs, you'll get lost, right? And the same is true for developing any system, is that if we don't look at the problem and analyze it first and make a plan we need to plan for how we're going to do it, and a plan for how we're going to make sure that it got done. Okay. So this slide right here is the most widely used process in the world. And the reason why is because it doesn't require anything of us. We don't have to have documentation that describes how our process works. We don't have to add anything. We don't have to use any tools to help us do our process. It's like I said, it's the reason why first-year programmers do this, because they just sit down and start typing, right? But for any project of size, for any project of any real size, this is not going to be an acceptable process, because it's going to cause a lot of problems, a lot of errors, and it will cost more in the long run. Okay, and that has to do with this next slide, the high cost of error correction. Okay, the reason why, what this is showing, what this graph is showing, and then this follow-up that's an act. So this graph is kind of a general idea, and then this next graph actually shows actual data from some different projects of how this was done. All right, so basically what this is showing is not how many errors happen at each of these phases, but rather the respective cost. So basically, and cost isn't just about money. Cost could be about time. It could be about people, about how many people do we have to put on this. It could be about tools, like if we need to get tools such as servers or other types of computing technology. But if we are able to catch an error in that first phase, in the definition phase, this would be the time where this kind of puts together the requirements analysis, the requirements gathering, requirements analysis, and design maybe might be part of that. Then development would be that next phase of the system design, but sorry, the unit design, the coding, the unit testing, that kind of stuff, and even some system testing. Then after release would be after it gets out to the customer. This would be after deployment. So if we think of, if we found an error, if we found a problem during that definition phase, if we think that costs, some factor of 1 value, that's the baseline. If that error manages to get through into the next set of phases, into that development and other stuff, then what can happen is that instead of costing 1 to fix that, it's going to cost 1.5 to 6 times as much, right? Because what has happened now is there could be issues related to the type of language, maybe the coding language that we used that now we're stuck with. This could be other things, man hours. We have people that had to go find out, well, why is this an error? Because they have to now to figure out why this solution that has an error in it does not accurately reflect their requirements. And after release, as you can imagine, would cost a lot more. Would cost a lot more to get this thing fixed. If you think about it, if Microsoft, for its next Windows operating system, if they're able to catch an error before it gets out to the customer, before it gets out to you and me, right, it will cost them a certain amount. But if that error, maybe it's a security vulnerability, right? There's an opening to a hacker or something like that. But if that same error were able to get out of Microsoft and into our hands, if it was able to be released as part of the operating system, and there's a security vulnerability, what has cost Microsoft in that? One, now they have to send a patch out. They have to rush a patch out, which is what? It's productivity time on me, who now has to wait for I might be in the middle of something and my computer has to restart. It might be something that costs me as well, because if it's a security vulnerability, it means my company might get hacked, right? Or might have some problem that shows up that was preventable, okay? And that's why it costs a lot more. So ideally, we want to catch errors early on. Right? We do not want them. Worst case scenario is errors get all the way to the customer, the user, okay? All right. So how do we catch errors early on? Well, one process that is widely used, okay, as far as other than the ad hoc process that I said earlier, we kind of say it's the most widely used. It's not really a process. It's just a write the code, right? But here, as far as a real process model is concerned, the waterfall is most widely used. And again, it's because of its simplistic nature. We understand this idea. We understand, okay, let's start with the first real phase here, the requirements analysis. So basically what happens is, the system engineering phase is basically the customer decides they need something. The requirements analysis is where we say, okay, let's take a look at what the customer needs, and let's really figure out what the requirements of this system are, okay? So, for example, a banking system might say, we need a way for our customers to get money, to be able to get cash, for them to be able to go spend money on things, all right? Well, we might say, okay, we could just do that through, they go into the bank and talk to a teller. But then the problem would be what? Why? We obviously know that was not a long-term solution. That was not a solution that was going to last forever because we have other ways of getting money now, right? So what's the most common way that you guys get money? That we can talk now. What's the most common way that you guys get money?
I'm not getting any money though.
You don't get any money?
I was thinking the same for that.
Only from mom.
Ah,
Yeah, that's the easiest one.
ah, nice. You don't have a bank account?
I do, of course, but I'm not working. I'm not earning.
Well, if you had money in your bank account and you needed cash, what would you most likely do?
Go to ATM and
Right,
withdraw.
exactly. So going inside of the bank and talking to a person and signing a form and all that, it's the old way. We used to do it that way, right? But it wasn't going to last because people need money outside of banking hours. You know, we need to be able to go at 8 o'clock at night and get money for something. So the requirements, so as we analyze those requirements, we say, okay, we need a way for our customers to be able to get money from the bank. So at some point, somebody decided, oh, well, what if we had a machine that they could get money from? Well, now, what does that lead to? Well, now we need to find a way to determine if the person, what account they're getting money from. Like how do we know who they are, right? And so that's when these, debit cards were designed and implemented, right? Is they said, okay, well, if they have the card, they put a PIN in, then we can know what account and they can get money. And this was, but even before the machine was made, even before the machine was designed, the idea of, okay, what are the requirements, right? What is it that we want to be able to do? And one of the requirements was get money from my account when a teller is not available, when a person who works for the bank is not available to give me the money, right? So that was a requirement. And so then once we have an idea of what all the requirements are for our system, we move into the design phase. And the thing about the waterfall system, the waterfall process is we don't move into the next phase until we are assured that the phase we're in is complete. So we don't move into design until requirements is complete. We don't then we design, and design is not coding. Design would be flow charts and pseudocode and stuff like that. Design documents. I had to write many design documents at my last job. So then we take that design. Once design is completely done, then we move completely into code, and all we do in the coding phase is write code. We may do some unit testing, some small level testing, but the majority of what we do in that coding phase is write code. And then we move into testing, and then where we test the code to make sure that it satisfies the requirements, and we move into maintenance. The thing about the reason why I said the reason why it's called a waterfall is, like I said, we only move into a new phase once we are done with the old phase. So if we think of, I mean, have either of you been to, like, there's a couple of waterfalls here in Antalya. There's a Duda and Shilalasi, and I can't remember the name of the other one. But you know what a waterfall is, right?
Yes.
So,
Yes, of course.
yeah, when water falls from the top of the waterfall down, like, it can't go back up, right? Like, water doesn't go up the waterfall, right? And so that's why this is drawn this way, and I can see how we only go down once we are done at the above the previous phase. Okay, it can be costly because sometimes we get to maybe we get into coding and we realize there's something wrong with our design, and so we need to go back into the design phase. But if we have this idea that we only got to coding because we were completely done with design, it can be costly to have to go back up into a previous phase. Okay. So that's basically the waterfall process. There is this idea that waterfall. So then there's this idea where there's just a lot of interconnectedness, and we'll get into one that's kind of like that. So waterfall with feedback, the idea basically is that as we move down into a phase, if we realize that there's some stuff wrong, we can kind of feedback into a previous phase. We can feedback and just maybe go back just to certain parts of the design phase if there's something wrong found in the coding. So prototyping. So the idea is we prototype the system. Now, a prototype is not the whole thing, and there's two different types of prototyping. One is called shallow and wide, and one is called narrow and deep. And the idea is, so you know what I can do? I can share. Downloaded this today for my other class, so I'm going to go ahead and share this with you. Yeah. So I think visually, and so I oftentimes find it helpful to have a visual thing. All right, that's from my previous. Oh, I did this. Okay. So this idea is that if this, let's say this is our system and it's divided into maybe certain sections. Let's see. So I'll just call it A, and each of these is like a different aspect of the system. So if it was a banking system, we might have investment accounts, we might have personal accounts, or sorry, business accounts, we might have personal accounts, we might have loans, and something else. If this were a university system, we might have something like over here is courses, over here is maybe sports programs. Over here might be the cafeteria or other shopping things or something like that. Anyway, so each of these represents a different section, like a different section of what our system should be trying to accomplish. So there's two different types, two different ways that we can look at prototyping. One is to say, okay, we are going to develop one part of the system completely. Okay. So maybe we say we're gonna develop the personal accounts aspects of the system for a bank completely. So that means we're gonna have the user interface for the personal accounts. We're going to have all of the security features. We're gonna have we're just gonna thoroughly develop that part of the system. Now, customer might be like, well, what about investments? What about this? What about that? So the prototype isn't for us to show you the whole system. The prototype is just for us to show you that we can develop one part of the system so well and so completely that you can trust us to develop the other parts just as well. Okay, so we don't have any stuff with like investments or business accounts or anything like that. Okay, another way that we can develop this prototype is, so this would be the deep but narrow. So notice it's not wide, it's not across the whole system, but it's one part of the system completely and thoroughly developed. Okay, another way that we could develop it would be shallow but wide. So we might get the basic aspect of each part of the system, but we're not going to develop a lot of the deeper parts of it. So maybe we might have a user interface for the investment account, for all the different types of accounts, and we might have some very, very basic functionality, but we're not going to do security for any of this. We're not going to do, you know what I'm going to do? I'm going to draw this in green to show that it's a different thing. Okay. We're not going to do security. We're not going to make sure that the user inputs, we're not going to make sure that the types of values, the user inputs are valid. We're not going to do making sure that the passwords are secure. We're not doing that. What we're doing is we're showing that we're getting a basic functionality of each part of the system. Okay, and basically because what the whole idea of the prototype is about is to spend a little bit of time at the beginning developing the system enough so that the customer feels confident that they can trust us going forward to develop more. Okay, so those are the two main types of prototyping that we do. You know, again, one is showing everything for one part of the system. The other is showing basic functionality for all parts of the system. Okay. Let's see. So we'll move back to those slides. Prototyping is really useful, especially for customers that want to be able to see something before they agree to complete the project with you, right? So customers, they like to see stuff, they like to be able to use it a little bit, and so that can be very helpful. All right. So with prototyping, now we will only do the prototyping mostly through these because prototyping is part of that requirements and design phase. Basically, once we get to the coding, we should only really get to the coding in a waterfall process that involves prototyping. We should only get to the coding phase once we know that the customer is okay with what we've developed so far. Like this is where we really get into the coding the whole thing. Okay. Have any of you had a computer architecture class?
Nope.
No.
I did in the past, and also about prototyping, I want to add something if you have time. In hyper-casual video games for mobile development, the companies are always using prototyping. They are doing a prototype, a game with not full features, a game that is complete in terms of gameplay, but not complete in terms of many aspects. So
Right.
they are doing the prototype and they are sending the publisher the prototype. And if the publisher says, okay, this is a good, they are making investment to you and you are finishing the game. I just wanted to add this. So.
Yeah, no, good point. Yeah, that's definitely, prototyping is very useful in games. In some ways, you could kind of think of for some of these phone games or something, that if you have a free version, it might be kind of like a prototype for the paid version. Because
Yes.
it a lot of times has a lot fewer features and a lot, it's not just about the ads. Right?
Yes, yes, not for ads. Also, for early access, there's something called early access. Also, a developer is creating like a vertical slice, but it's also a prototype, right?
Mm-hmm.
Yes, it's also a prototype. Yes.
Right. Exactly. All right. So the reason why I asked about the computer architecture is if you know the idea of a pipeline in a computer architecture instruction pipeline, this may remind you of that. So the idea of this incremental, it's kind of like a waterfall, but the idea is that, so while we are doing analysis of the first phase, like this, we divide these into phases, divide the tasks into phases. And what we can do is we can have this analysis of the first phase. And then while we're designing, this is requirements analysis. And while we're designing the solution for this portion of our product, of this portion of our software, we can be moving on into analysis for a different portion. Okay? And then this moves into code. This portion of it moves into design. This portion starts being analyzed. And so we kind of like are able to flow together. One of the reasons this could be used when in a situation this could be used would be especially if we have a large group of developers, and if certain ones are in charge of analyzing aspects and another group maybe some overlap, but another group is in charge of designing, another group is in charge of coding. And this has to do with, and what I mean by that is, if I am really good at coding, if I have a solid design, and I'm really good at taking that design and converting it into code, but I'm not really good at making the initial design in the first place, then what we might do is we might take someone else who's really good at designing and have them design and then move it on to me to code. And then while I'm coding, they can be working on the next design. And so we kind of can divide up those man hours, right? And from a personal experience, this can work better. And I say that not from a position of a company that used this type of incremental process, but rather one that used a waterfall process. But basically, I was good at designing and coding, but not as good at in those days as at the requirements analysis. But yet I was on a team, and we were kind of all in charge of doing all of it, right? And so, yeah. So if you have somebody who just does not know how to test, does not know how to, we shouldn't ask them to be in charge of testing portions of the system. All right. So another idea. So if we take this incremental idea and instead say, what if we did a complete development of one portion and then scrolled back around and did it again for another portion or an expansion, and then we scrolled back around and did it again for another portion or expansion. And this would be kind of like the spiral model it looks like, right? So basically what happens is you know, we have this planning portion, the evaluation, you know, and development, and we spiral around, and we always get back to this spot where before we move on, we have this what's called a go, no-go decision. So based on analyzing what we've done so far, if we get a no-go, we just go back to this part, okay? And I guess actually it spirals out. I shouldn't say spiral, because it spirals out to encompass more of the thing. So we plan, we analyze, are we ready to go? Yes, we continue on into development and testing. Then we plan more, we plan the bigger part, so we're moving out. So if we imagine that this outer ring represents the entire system, designed, coded, tested, and implemented and deployed, then as we take a small section of the program, a small section of the system, right, and then we plan it out. Yes, we can go. We develop it, we evaluate it, we test it, we plan the bigger section. How does it fit in with what we've already done? How does it work? How are we going to move on? We plan it out, we analyze, we get ready. Before we move into the development of the bigger section, we say, okay, are we ready to go? And we keep moving out. So this is another process that are sometimes getting used. Right? A spiral with more phases, more aspects to each of the phases instead of the 4. We add construction and releases the development phase. Engineering kind of becomes a part of that. Customer evaluation and customer communication instead of just the straight evaluation phase. Because one of the things that we have to remember is that if we have a good customer, they will have their own testing as well that they want to do. Okay. Oh, one other thing I'll say from a personal experience here, I may have shared this last week, but we also, in that customer communication, we need to have solid solid acceptance criteria. I did have a personal experience with one company I worked with where we allowed for the customer to accept or reject based on whether or not they felt okay about it. It wasn't they couldn't pinpoint this is wrong, this doesn't fit the requirements, but when they used the program, they said, yeah, it works, but it does everything we asked for, but we just don't like it. We don't feel good about it. And somehow for our company, the company had allowed for that to be a reason for them to reject. And that would be the kind of thing that you want to make sure back here in the early phases, the requirements and stuff like that, that way back here you say, this is the type of things that we will allow for rejection. These are the types of things that, yeah, I understand it. You don't really like it, but no, that's not a valid reason to reject. So, all right. Let me skip on over into this one. Okay. So some of the process characteristics, if the process is not understandable, if you don't have employees that understand, how the process works, then it's going to be a problem. All right. Visibility, supportability. Okay, what do we have tools that are allowed to be able to support them? I talked earlier about configuration management, about this. So the way the configuration management was done at the last company I worked for was we had a configuration management tool, and we had a person, their job, they were the configuration manager. And what his job was if I needed to change some code in order to satisfy a requirement, we were in the maintainability, we were in the maintenance phase. If I needed to make a change to satisfy a requirement, a bug fixing, whatever, I had to send a request to him for him to release the code. Now, and all he would do was he would change the status of the version control system we used, that we would change the status of that file to make it to where I could grab it, I could get it. Now, once I did, I had it, no one else did. Okay. Now, it may sound like a lot of work, it may sound like a lot of problems, but this actually worked out really well. So what would happen would be if I needed to work on something and somebody else needed to work on the same file, the same code, then if I got there first, if I realized I needed it first, then what would happen is they would have to wait till I was done with it, and then I would send it back into the version control system, and then they could grab it from then on. Okay. Now, the reason why I say this was because the job I had right before that one, the person that was the configuration manager for that project operated in a very different way. And what this person would do is, instead of having an automated tool that controlled access to these files, what would happen is if I needed access to a file, I would, like with the other guy, I would send him an email. He kept up with it in his own personal Excel spreadsheet, who had access to what files, and then he would send me a copy, and he would note, and then it was all on him. Well, what happens if he messes up? What happens if he forgets? What happens if I request it? He sends me the file. He forgets to put it in his Excel spreadsheet, and next thing you know, my coworker says, "Hey, I need the file," and he sends it to them too. Right? That can be a big problem. So the automated tool, as far as the supportability is concerned, so the acceptability, and that's probably the biggest one. We call this buy-in. Is if the personnel, if the software developers, if they don't believe in the process, then we're going to have problems because no one's going to want to use it. And that was probably one of the jobs I had where not a lot of people really bought into the process, the way that we develop software. We had a defined process, but really most of the developers just wanted to just write code and not have to deal with all the other stuff with design documents and testing and stuff. And so if your employees don't buy in, you're gonna have a hard time using the process. So, all right. So that's basically an overview of software process. Are there any questions based on what we talked about so far?
I haven't used it, but most of my friends who are working now, they say that Agile is the best. Agile rocks, something like that. Have you ever had a chance to work in a project with Agile? Is it something that's a game changer that much?
So I haven't. Like I said, the last company I worked for, we had more of a waterfall process. So we would write that we would do the requirements analysis, then we would do the design document. Maybe the closest I've gotten to agile development would be a couple of years ago. We used as part of our CSE 102 class, we introduced the students there to what's called the Scrum process. Scrum is kind of in some ways like the what we'd call the incremental development, where you do portions of it and you move. So this task is moved from design into code, but we don't do the whole system from analysis, design, code, and so forth. What we do is, I guess you're seeing me this way, so design, no. But instead, what we do is we say tasks. We divide the whole thing into a set of tasks, and then we say, okay, what we're going to do is we're going to work entirely on this set of 10 tasks, and we have 2 weeks to be done with these 10 tasks. And then as the tasks are, as it's analyzed, it moves that task into the design phase. And then once it's a design, it moves that task into the coding phase. And so that was a pretty neat one for me because I'd read about Scrum, but I'd never really seen it. So that was a neat one for me. But no, I've not done anything with agile development.
Thank you very much.
Sure. I just realized that I gave you guys an assignment last week, didn't I? Well, not an assignment, but like a discussion questions. But I didn't talk about them yet.
Yeah, I remember that.
So, did you think about the questions? Did you?
Actually, I kept thinking about it. I also had a chat with my friends about it. I also asked them the same questions with few friends. But first, can Tahir talk, because in here there's a loud place right now.
Okay.
Later, can I?
Sure.
Actually, I was missing last week, so I have no idea what questions were they.
Oh, okay. Here, let me share this. I'll share the this with you, the screen. So this was what we ended. So I encourage you to go back and watch the video because I record. This is being recorded, right? Yeah. Okay. Good. I wanted to make sure. That would have been bad. Okay. So this is what we after I did the course information, the syllabus type of discussion. So I left out with this week to consider these following questions, and this is what I said we wanted to kind of have a little bit of a discussion about. What I will do is I'll say for those who are watching at home, those who are not watching this live, you're watching this on video later. I would like to hear your input on this. So maybe if you can either record a video or write up something about your thoughts on these questions, then I would like to discuss them. So, all right. So I'm going to start with this first question then. Okay. So what do you think? How can we be absolutely sure, like 100% sure that a system works? Like, how can we go about doing that? What do you think?
So I think it's impossible to know. We cannot be sure because software itself is fragile, and the hardware we are using software is also fragile. So it makes things hard. But how do you make sure that the system works can only be answered by time, I guess. So when you build a project, you will only learn the real problems and the real you'll get the real feedback once you release it. So for example, I'm always giving examples from video games, but many video games goes into a long testing phase, but everything changed after it releases because when it releases, millions of players are playing it. So, but in your company, you don't have that. So I guess system never really works that good. It needs update and update and update. I think it's nature of software, in my opinion.
Mm-hmm. No, I agree. I would like to hear from Tahir if he has any thoughts as well about any of these.
Also, if we consider security of software, I don't think there is a software that is completely secure. Even iOS or some other secure operating systems are hacked due to their vulnerabilities. So I agree with Osman actually. It's impossible to be sure, I think.
Okay, good. Yeah, I agree with you, and we'll talk about why in just a moment because there's another question that kind of leads to that. So how do you define quality? Like, what do you think it means for something to have quality? And this doesn't have to be software alone. This could be anything. How do we know that a car has quality? How do we know that when you go to the bazaar and you go and you get fruit or vegetables from the bazaar, how do you know what quality fruits and vegetables are?
So to me, equality is not a word I can describe with sentences, but for example, a good presentation makes the thing feel more premium. So when like my dad has a small pet shop, and we are trying to smile to the people, and we are trying to keep the place clean. So that's how our customer says that, wow, it's a quality pet shop, for example. And it's the same for software and also other products like cars. Like, for example, you don't see a commercial in television for cheap cars, but for expensive brands, there are many good commercials, ads, and they are like, how can I say, they like, for example, I know that we cannot, I don't want to give name while in recording, but some car manufacturers give discounts to prestigious people to buy their car, for example. So I think it's all about presentation. What defines quality is presentation, in my opinion, at most.
Okay. Tahir, what do you think?
I think quality has got many aspects. Some of them could be being able to use the software or the product for a long time, for long term, and user-friendly and secure products also can be called as high quality products. And we can find some more aspects also, I think. I mean, everything should be good for high quality.
So is quality related to cost? So if something costs more, does it mean that it's higher quality?
I don't agree with that, as I stated. So maybe it costs less. For example, the tablets we buy, the phones we buy, they don't cost that much compared to the selling price, but they feel quality products. But to the how can we say, to the developer, to the publisher of the product, they are cheap actually. But
yeah, I think it's interesting because like even like I'm wearing these headphones right now. So my wife wanted me to get some headphones from some Bluetooth headphones for her, and basically I got these. I found these headphones at A101 that are, I think brand is Ghostmark or something, but they're basically like they look exactly like Apple earbuds, Apple AirPods, and they plug into the same type of plug and everything. And she says they work great. She loves them. And then I was at Migros a couple of days ago, and I saw actual Apple AirPods. And so the ones at A101 that Go Smart were 50 lira, and the ones at Migros were 1,400 lira. Yeah, and for her, does she need the Apple earbuds? Does she need, or these other ones work just fine, right? And so, no, absolutely, yeah, you're right, absolutely. Quality does not have to mean price. It's interesting that I may have to find this. Let me find a paper that talks about this and share it with you. But I remember reading about years ago that some car manufacturer, speaking of Osman, sorry, Alper, that you said the car manufacturers. So lots of people believe and know that Mercedes is a very quality car, is a very quality automobile. But what this company had done is they had taken out this, they had done this research that had shown that even though their car was thousands of dollars cheaper than a Mercedes, it was actually, in a lot of statistics, was a much better car, was a much better vehicle. And yet, the funny thing about it is that even though they had done all this research and they put all these advertisements out to show that they were a better car, the increase in sales for them and the decrease in sales for Mercedes was nothing. They still didn't they didn't gain any customers from Mercedes. All right, people still saw the word Mercedes and thought that's a good car. All right, and so I think that's pretty interesting that we kind of can have this idea that a name could be a good product. All right, so I'll buy a Sony TV, but I don't know about this other brand that I've never heard of before. And they may be the exact same television, the exact same product. So I said I would get back to this absolutely sure question because this next question kind of connects to it. Is so we're going to talk extensively later in the semester. We're going to talk extensively about testing. So what do you think? Why should we do testing? What do you guys think?
So, not to be a Note 7 disaster, if you ask me. Like Note 7 or 8, I don't remember correctly, but you remember that the battery explosion, right? They later announced that it happened because they did not do enough testing with the battery and the charger. But it was a catastrophic event. They collected all the phones. I remember that back in the time, there was no pandemic and we were still able to fly. And in flights, they were like asking if you have a Samsung phone. Because if you had one, they were putting it in a protective box and they were turning it off, removing the battery, putting battery into a cold place, such as so. It was a disaster because of the testing, and the testing prevents bad outcomes that may later come. And also in the development part, as you said, I think we're gonna speak about this a lot in this lecture. But actually, mostly in software, if you go without testing, from my personal experience, things will never work out. Testing is essential in software, and I think in everything. So that's it for me.
Yeah. Good point. Can we prove that a system works through testing?
Partially, maybe.
Yeah. The reason why I ask this question is because many times people think of testing as being a way that we can prove that something works, when in actuality, because especially of the size of the systems that we run now, you can't prove 100% that something works. What testing does, and it sounds bad. Programmers don't like testers. I told you guys last week, my first job in the tech field was as a full-time tester. I think they gave me the title of test engineer or something like that. But my job was to test the software. My job was to test the code and make sure that it passed these tests before they went out to the customer. But programmers didn't like me. And the reason why was because my job was to find places where their code didn't work. That really was what my job was. So the purpose of testing, at least, as far as the literature is concerned, as far as what I'm going to tell you, is the purpose of testing is not to prove that something works, but rather to find the places where it doesn't. And so like what you said, Alper, with the battery, is had they done more testing to make sure that the battery didn't explode, right, then we would have seen that it did. They would have had some experience with that this error happened, this problem happened, and they could have fixed it before it got shipped out. And so it's kind of like, I'm not going to do much politically or anything, but you know that America has an election coming up. And there's people that talk about, well, we need to not do so much testing because the more testing we do, the more we find out that people have the virus. And it's like, no, that's kind of the purpose of the test, right? The purpose of a COVID test is to find out if you have the virus, right? Or if you are contagious. And so that's kind of what we do with software testing is it's not, in other words, the test isn't to prove that someone's healthy, the test is to find out who's not. And so in the same way with the software testing, it's not intended to prove that a system works, but it's intended to show where it doesn't, so that we can fix those problems so that our customers can have confidence in what we've produced. So I won't go to the last question on there. I do want you to go ahead and maybe think about that and think about how much time should we spend during the development phases on all these different things, the requirements, specification and analysis, design, implementation and coding, testing and deployment. Of the overall development time, if the overall development time is 100%, if there were 100 days, for example, how much time would you think how many days do you think we should spend out of 100 on doing each of these? And so maybe comment inside of the chat for this class, for this lecture. I don't even want to call it a lecture. There's more discussion. Yeah, discussion. Comment on the chat inside of this discussion for that. Okay. All right. Let's talk. What we will do is talk about. Oh yes, Tahir, you raised your hand.
Yeah, by the way, I uploaded a presentation about quality management if you want to check it out.
Oh, perfect. Thank you. So where did you put that?
There was a page in Microsoft Teams called Files near Posts. There's a tab.
Okay. I'll go take a look. Oh, it's coming up. Oh yeah, this Gurus of Quality. Okay.
Yeah, not very much good maybe, but some pages might be useful.
Okay, cool. Thank you for sharing that. Yeah, please do that. Please, as you find things that you think might be of interest to us or to interest to this class, then we can put that uploaded into that files location. Perfect. Good use of that. All right. Oh, I'm already sharing this, so let me share. And so we'll finish off our discussion with the capability and maturity discussion. Okay. So we talked, like in the first part of this discussion, we were talking about, let me change this. We talked about the different processes, but how can we tell if a process is good? Because even we're talking here about quality, right? How do we know if a certain process is a quality process, is a good process for our organization, for our company? And so the idea is this, what we call this maturity, this capability maturity model, is this idea of taking what aspects of a software process model are we implementing, are we including, and the more higher level, then the more we can have confidence that the process is developing quality software. Okay, and what I'm basically, it's kind of like it's an analysis of the process that we are using and how we're going about developing the software. So if we think of like this CMM levels, right, is you have this initial, which most companies are going to be down here at this level 1. As far as what's called the CMMI level, they have this 1, 2, 3, 4, 5 rating scale. There are very, very few companies at level 5. It's very rare for a company to get all the way up to level 5. But that don't think of that as a bad thing. It's just that not a lot of companies need to be at that level, right? Really, for the vast majority of companies out there, where you want to be is you want to be right around level 3, okay, right around in the middle. So then we think of it as basically level 1 is practically no process at all. We're not really using a process. We're just letting developers design and develop code however they think is best. We don't really have much of a check. It's not that design isn't happening. It's not that that testing isn't happening. It's just that we don't have any requirements at the organizational level, right? We just kind of let people do what they want to do. And if one developer wants to use a lot of stuff like design and test, and another developer wants to not, we're fine with that. Okay, so again, it's not that none of those things aren't going on. It's just that we don't require them. Okay? So this level 2 is like, we have a process, we have some kind of configuration management, we have a project plan, we have requirements management. So we actually check on these things. So we're making sure that requirements are properly analyzed and obtained. We're making sure that some testing is going on. So it's we call this the repeatable level. Then we have this level 3. Like I said, most people are at this. Most companies, most quality, most well-known, solid companies are going to be at this defined level. So we're going to include in this peer reviews, which what that means is, so if at the repeatable level, if we require design documents, for example, maybe you require before you write any code, you have to have developed a design document. Okay, that's fine, that's great. But what if I write my own design document and then I write my own code based on my design document? I might not catch my errors, right? I might not catch my errors in my design before I get to my code, which kind of the whole point of having a design document, a design before you go to code, is to catch errors in the design phase rather than letting them get into code. Peer reviews, and this was what the last company I worked for, I believe we never got like evaluated to determine what level we were at, but I believe we were at a level 3. Okay, so we had what was called peer reviews. So what would happen is I would write my design document for this thing, for some feature we were adding or for some bug we were fixing or whatever. And I would take my design document, I would schedule it. Once I was done with it, I would schedule a meeting and I would say, okay, we all need to meet on Thursday at 3 o'clock and we're going to discuss my design document. And we would all get together, we would sit in a room, we'd all have printouts of my design document, the other developers on the team, and there was also the configuration manager was there, and I can't remember the other guy's name was Tom, but I don't remember what his title was. But he was someone that was like a go-between, someone that talked with us as developers, but also talked with the customer about what they wanted as well. But he wasn't a manager, I just don't remember what he was. Anyway, he would be there, and we would review the design document, and until everyone on the team signed off on the design document, until everyone on the team said, yep, we're good, this looks like a good design document to me, I wasn't allowed to write any code. Once everyone on the team said, yep, this looks good, now I was released to be able to go take that design document and make it into the code itself. Okay, so this kind of helps with making sure that this peer reviews kind of helps making sure that the person writing the design document really does a thorough job of understanding the design before moving on into code. Okay. Then you have these other higher levels, which they have a lot more strict requirements and a lot more. I can't think of the word, but like again, if you are evaluated to be at these higher levels, again, what it means is that you probably are at least we know that you are developing code in a consistent quality way. It does not necessarily mean that all of your code is quality, but it means that we can be more assured that you're at least going through the process in a way that makes sense, in a way that's helping you develop quality products. Again, like I said, most companies, level 3 is fine. I would say you would like to have, especially really large companies, really large software.
Sesim geliyor mu?
Evet. Ben duyuyorum da.
Galiba hocanın interneti gitti.
Evet, az önce de bir sessizlik olmuştu.
Benden sandım ben. Mobil veri değil mi
Ben
ya?
de o zaman benden sandım.
Aynen. Bekleyelim.
Hoca Türkçe biliyor mu?
Galiba bilmiyorum. Soralım.
Hoca komple düştü zaten şu anda.
Evet. Neyse bekleyelim biraz.
Hocanın bugün pek ders yapmaya niyeti yoktu. Sanki de bizi istekli görünce sanki uzun tuttu.
Yok ya, 2 slide yüklenmişti zaten. Sanmıyorum öyle bir şey olduğunu.
En başta dedi ya çok zamanınızı almayayım falan. Slaytlar bu arada nerede? Ben bulamadım.
Ekiplerden genele gel. Ee, yani software quality'nin. Bu arada ben chatten bir yazayım da. Tamam. We are waiting. Neyse
Are we still there?
Okay, yes.
Yeah, I don't know what happened.
Uh,
My Wi-Fi just suddenly said there was no internet, and okay.
Because you are living in Turkey, I think.
Is this still being recorded? Yep, it's still being recorded. This actually happened earlier. This happened earlier on in my first class too. Ugh. And the funny thing was I just so I have Turkcell Super Online, and I just had them upgrade the speed last night because of a lot of problems we were having. Speed doesn't seem to be the problem. The router seems to be the problem now. Okay.
To me, the biggest problem is about the electricity and the internet. Sometimes the electricity will go, and sometimes the internet. You don't know which and when.
Also water though.
Yeah, water sometimes.
We've never had any problems with our water, but we've lived in Ankara and Antalya, so I don't know if that helps, being that both that have larger foreigner populations. I don't know. Anyway. Okay. So where were we left off? I don't know.
Most companies was on level 3, and we were just about to finish this part.
Yeah, yeah. I said, well, one of the things I said was, and maybe the government heard me and they shut me down for a second. I don't know, but one of the things I said was, the last time I looked into this, I think it was about 10 years ago or so, to see where different companies were on the CMMI levels, and most, you would think that, okay, so you would think that large companies, especially what we call mission critical companies. Mission critical meaning that, like, if it goes down, that means big problems. So, the banks in a country would be mission critical for keeping the economy up. The stock market in a country would be mission critical. So you would think that a government company or organization would be higher up on the level. I think last time I looked into it, like I said, over 10 years ago, most government projects, most government institutions were here at the level 2 or a bare minimum level 3. And so it's, but part of the problem is because government also, by its nature, is slow, right? They are slow to adopt new technology. They are slow to upgrade their systems, because it's kind of the attitude is, this has worked for so long, why do we need to change anything? All right. And now that's, I don't know about Turkey. When I say government organizations and I say what I was reading about, like where different companies are on this level 1 up to 5, is all based on America stuff. So American government projects are usually at these level 2 when you would really expect them to be even at high level 4 or level 5. So, that's how it works. All right. So
if I remember correctly, I was listening to a seminar about this, the government software issues. I heard that USA is one of the worst. Even in Turkey, we have something called e-devlet. Right? I heard that in USA, it's something impossible to do, since all states are following different laws like that. So. Yep. I think it would be very, very hard to develop something like this in USA because of that.
Right, because the United States does a lot of stuff based on the local state governments. Actually, you bring up a very interesting point too, because one thing I was very impressed by about when I moved to Turkey was the banking systems here, the banking of how I access my bank account. And the reason why I'm going to talk about this is because, so you guys understand security a little bit. You know what 3-factor authentication is, so there's 3 types, 3 factors of authentication, and the way that we define them, the way that we look at them is, 1 is something that a user knows. So that would be your username, password, for example. 1 would be something that a user has, like it doesn't have to be a technological device. It could be something as simple as your what is it? Your Kinlink, right? Your ID card could be something you have. You have that in your possession. And the final thing is the way they define it is they say it's something that a user is. So what we would say is like your biometrics. So your fingerprint is something who you are. It's not. You don't have a finger. It's like your fingerprint is part of who you are, or your eye, your retina scan. So if you think about it, when I go to the ATM, like when I'm going to hold this up if you can see it, right? My TEB card, my ATM card. When I go to the ATM, I use what's called 2-factor authentication with this, because I have to have the card, but I also have to know the PIN. Right, the code that I have put in for this. So the reason why I talk about this is because actually it was probably about 10 years ago. The United States passed a law in an effort to try to be more secure that required banks to use 2-factor authentication. They didn't care what 2 factors. They just said you have to have 2-factor authentication for people logging into their bank account on websites. Now, at the time, I worked for a company that for one of the systems that we logged into, they used this what's called a key fob. It's a little USB stick size device, And what would happen is I would go to the website to log into my account. This wasn't my bank. This is my company. Well, go to the bank, go to the website, type in my username, type in my password, click OK. Then it would say, please enter the 6-digit code on that little key fob. It was a randomly generated 6-digit code. I would enter that. And what that did was it said, okay, he knows his password. He has the key fob because he knows the 6-digit code. So therefore, he knows something. He has something. That's two-factor authentication. Okay. The reason I'm getting into all this, so the law was passed that required banks to have two-factor authentication. So we expected, okay, what's going to happen? Banks are going to have to start sending people these key fobs with the randomly generated number. What the banks did, though, was they said, actually, what we're going to do is we will have a second security question. So now, if I were to pull up my bank website right now, and my American bank website, and if I were to log in with my username and password and click OK, it would then come up with a second question that would say something like, what's your mother's maiden name, or what was the name of your best friend in high school, or something like that. And the banks convinced the government, the American government, that was two-factor because it was two separate security things that they needed to enter. But in actuality, that was not two-factor authentication because it was two forms of the same factor. It was both two things that a user knew, right? So why did I say this to compare America to Turkey? Then I come to Turkey and I get my bank account here. And what happens? I get into my bank website, type in my username and password, and I click OK. And then what comes here? To my smartphone. A text message comes to my smartphone that says enter this security code. All right. What is that? That is true two-factor authentication. Because now, not only do I know my password to my bank account, to my username and password, but I also have shown that I am in possession of my phone as well. Okay, so if you ever noticed in like spy movies and other like James Bond and those types of things, a lot of times they use this three-factor authentication for really secure places for people to get into, where they will type in a password and then they will they'll put in their security card, they'll type in their password, and then it'll like scan their eye or something, right? And so this is like three-factor authentication because it's all three different types of things. So congratulations to Turkey. You guys do banking better than America does. So anyway, that's me frustrated about how things work in my own country sometimes. So, all right. So speaking of that, so moving on to the whole idea of what is maturity and what is immaturity as far as the software development is concerned. Okay. Characteristics of immaturity: if the software process changes during the course of a project. So if we start out with a waterfall and we say, oh, this isn't really working well, let's change to a Scrum process, or let's change to agile development. If we're constantly kind of changing things up, that means that we have an immature situation as far as capability is concerned. Right? It's not trustworthy, right? It's that even the process of how we develop the software can't be trusted that it'll be the same today and tomorrow and next week. Right? The process might be specified, but it's not followed. We don't have buy-in. We have developers that they don't believe in it, so they don't use it. Right? Reactionary, like we're like, okay, let's solve immediately. Let's squeaky wheel gets the grease kind of mentality. That if something comes up, we'll fix it. If something doesn't come up, we'll keep on going. Some other things. The quality is difficult, if not impossible, to predict. One of the nice things about the whole having a software process is we can have a pretty good idea of what level of quality our final product is going to look like. Okay. Oh, this one right here, the no objective basis. that was what I was using as an example earlier. If a customer, if a user, if we're allowed to not accept the product based on, I just don't really like it. I don't think it's good. Okay, well, what's wrong with it? Well, I don't really know. I can't find anything specifically wrong, but it just doesn't feel good. Like, that's a bad thing. We want to have objective, quantifiable reasons to be able to say, this is correct, this is not, this is acceptable, this is not. Okay. So on the flip side, if we're looking at characteristics of a mature system, all right, we have a process in place and it's enforced, and our employees use it, and they've seen that quality is measured and monitored, and they've seen that quality products come out of our process. Okay, again, workers see the value in the process. Roles and responsibilities within the process are clear. In other words, we don't have people doing jobs that they aren't really supposed to be doing. If we have software developers that are doing the jobs of configuration managers or system administrators, that can be a problem. Now, that's not to say that doesn't ever happen. Sometimes you might have a configuration manager who is also one of the developers. That may happen, but we have to make sure that those things are clearly spelled out at the beginning, and they're not fluid. Like, it's not like a configuration manager has to take on the role of software developer at the last minute because the previous software developer just isn't understanding what he's doing. Okay. Let's see. Okay. So there's a Motorola document in that. You can't see that. I'm not sharing that part with you. I wanted to, but it only shares one screen at a time. I put what's it called? In that folder, the readings folder, there's a file called, where is it? Your process improvement for Motorola. That's related to this. So so if you want to read about how Motorola was able to generate some software quality, some quality product through following a mature process. All right, so there's some different examples in there. So the CMMI, kind of a leveling system for understanding how we can assess the maturity of a software process in an organization. And what can happen is that if, again, the higher level quality organizations, will know what CMMI level they're at. So if you go for an interview with a company and you ask them what CMMI level they're at and they have no clue, they're probably at a lower level. So, let's see. What else do I want to? So I'm seeing what else I want to go through over this. I'm going to go ahead and end this class in about 10 minutes or so. Let's see. I want to see if there was something else specific I wanted to go through on here. Oh, so these are some of the maturity levels and how they're defined and how some of the aspects of those different maturity levels. All right. Okay. I mean, if you want to read up more on that, there are some documents, like I said, in the readings that have to do with CMMI and maturity levels. So if you want to look more into that, you're welcome to go ahead. I do want you to read the documents that are there. So what I would like, and what I will do is I will write up an assignment description for this. The first kind of graded assignment that we're going to do here is I want you to do kind of a form of like literature review, but more just kind of a summary of. So what I would like you to do is, so the first 6 documents in there. So each one is 02, 03, 04 are kind of based on the lecture number that they'll be mostly associated with. Okay, and so for 2, 3, and 4, that represents 6 of those papers. I would like for each of you to choose one from each of those numbers. So read the paper that starts with 02, choose one of the 2 that starts with 03, and choose one of the 3 that starts with 04, and just kind of write a summary of each. Okay, it doesn't have to be long. It doesn't need to be like, I don't want to put a page requirement on it or anything, but I do want you to, in the next 2.5 weeks, to read those papers and write up a summary of each that substantially kind of talks about what the main points of each of them is. Okay. So if that's clear.
When is the deadline?
Probably, let's see, maybe 2 weeks. Yeah. Because I really want to go ahead and assign the information for the paper and presentation as well. So let's go ahead and make that a 2-week deadline.
And also, which papers do we need to read? I couldn't get that part, the 02, 03 part.
Okay, so there's one paper that starts with 02. That's from the second set of lecture slides. It's related to the second set of lecture slides. All of you need to take that one. Then there's 2 papers that start with 03. Choose one of those. And then there's 3 papers that start with 04, which is actually the next set of lecture slides that we haven't done yet. So I guess I can't make it 2 weeks from now because we're not meeting next week. Make it 2.5 weeks. I'll give an exact date, but 2.5 weeks. So I'll give an exact date on the assignment description. But so anyway, so basically I want you to, from section 2, section 3, and section 4, I want you to choose one of the papers from each of those. So 3 papers. So 3 papers total, 3 summaries total.
Okay, now I got it. 1 paper from each section until 4.
Yep.
Okay.
I'm good. Okay. Any other questions?
No, thanks.
All right. Well, thank you
you
guys.
for the lecture.
Yep. Have a good weekend. And we're planning on not meeting next week because of the holiday on Thursday. So go ahead and take Friday as well.
Oh, okay. Next week, no class.
Yeah. No discussion. No discussion time on next Friday.
Okay.
Seems you have been in Turkey for a long time. Even I didn't know next week is holiday.
Thursday, it's Cumhuriyet Bayram, right?
Yes.
Yeah. So normally we would have like a nice event at one of the schools, but not this year, I don't think. Unfortunately.
And also, do you know Turkish?
Biraz Ankara'dayken ders aldım. Ama pratik yapmam lazım tabii ki.
Anlıyorum. Kolay gelsin o zaman.
Size de kolay gelsin.
Sağ ol, teşekkür
May I
ederim.
ask, why did you immigrate to Turkey?
Well, so we lived in Ankara for a 1.5 years while I was working on my PhD. And then we fell in love with the country while we were there. This was 6 years ago. And so, and of course, now we get to live in Antalya. So, there's not, what is it, on the hill nearby Atatürk dedi, hiç şüphesiz ki Antalya dünyanın en güzel yeridir. All right.
Evet.
So, yeah, it's nice. But we love the Turkish people, and we want to be able to. I love teaching, and it's amazing to be able to be here.
I see.
I'm looking forward to leave this country, actually.
Should I stop the recording?
I don't care though.